Hi class, this is the second video or lecture for class 3, part 2. In this video, we're going to talk about beta. Okay, so beta measures a stock's market risk and shows a stock's volatility relatively to the market. Again, we talked in the first video or the video before this video that beta is how much the stock contributes to the market risk. So that's why we used market risk premium multiplied by beta. So we have stock risk premium. Okay, that's why we say beta measures a stock's market risk, or how much stock contributes to the market risk. Okay, it's the relation of the stock's risk or stock's volatility relative to the market portfolio. It shows us the extent to which a given stock's return moves up and down with the stock market. It indicates how risky a stock is if the stock is held in a well-diversified portfolio. Again, it tells us, it measures the stock risk premium if we use it to multiply by market risk portfolio. Or multiply it by market risk premium. Okay, and for market portfolio, we can treat it as an average stock. If beta equals to 1, the security is just as risky as the average stock. If beta is larger than 1, the security is riskier than average. If beta is smaller than 1, the security is less risky than average. Most stocks have betas in the range from 0.5 to 1.5. Can the beta of a security be negative? Yes, if the correlation between stock I and market is negative. Okay, rho, the correlation between the stock I and M market could be negative. If the correlation is negative, the regression line would be downward sloping and the beta would be negative. However, negative beta is highly unlikely. Okay, when the correlation between stock I and market is negative, it means stock I's return moves in the opposite direction as the market return. Okay, remember these apply to the countercyclical stocks we've discussed before, right? Calculating beta. A typical approach to estimate beta is to run a regression of the security's past returns against the past returns of the market. The slope of the regression line is defined as the beta coefficient for the security. Okay, so we are actually using capital asset pricing model to calculate beta. Okay, I'm rewriting the capital asset pricing model here. It is the stock risk premium, RI minus RRF, equals the market risk premium, RM minus RRF, multiplied by beta. Okay, and we are running this, we want to calculate this beta. Okay, so we want to run this model for a lot of times by using historical data of market return, risk-free return, and stock return. Okay, if we use like 10-year, 20-year, or 30-year data of all these other 3 variables, okay, and run a regression line, we would have an estimated beta based on historical data. Okay, because if we rewrite this model, we can write RI as our left-hand side variable on the equation, and on the right hand of the equation, we have beta I multiplied by RM minus risk-free rate multiplied by beta, and we move risk-free rate to the right-hand side. Okay, so you can treat this RI as Y. Okay, treat RM as X. So beta would be the beta coefficient for X. And this, the rest of the equation, minus RRF multiplied by beta plus RRF. These would be the constant in the equation. Okay, so this model would be in the format of y equals a plus bx. Okay, this is a typical equation you would see in your math class. Okay, now we have enough information on y, a, and x. We run this regression line for a lot of times. We can have an estimated beta coefficient or this b coefficient here. Okay, for example, if we know Rm, Ri for these 3 data points shown in this graph, we can draw this line based on these 3 points. Okay, this regression line is the capital asset pricing model for stock I. Okay, and Ri becomes negative 2.59 plus 1.44 Rm. So this 1.44 is our estimated beta for stock I. Okay, and Rm here, we treat it as X. Ri here, we treat it as Y. Okay, so here we can see that for treasury bills, beta is 0. Okay, because Ri stock return is always constant. It doesn't change when Rm changes. For high-tech industry, beta is 1.32. It is positive. Okay, the line is upward sloping because high-tech is cyclical. Okay, when Rm goes up, Ri also goes up. But for special industries like collectible firms, we've discussed before that it is countercyclical. So when market is going up, Ri is going down. Okay, so beta is negative here. The regression line of the capital asset pricing model is downward sloping. Comparing expected return and beta coefficients. We have 5 securities here we've discussed before. We list their expected return and their beta here. Okay, for these 5 assets, we've discussed their standard deviation and coefficient variation, right? And I'm listing here too. Again, SD and CV were the measures for measuring the standalone risk of the stock when we're holding just one stock. But beta is the measure of the stock, the risk of holding this stock in a well-diversified portfolio. Okay, so both beta and standard deviation are risk measures, but beta is the stock risk when we hold the stock in a portfolio. Standard deviation is the stock risk when we're holding this stock by itself. And riskier securities have higher returns, so the rank order is okay. Okay, when high-tech industry, it has the highest return, it also has the highest beta, highest standard deviation. Okay, and as the return goes down, we see beta goes down and standard deviation goes down. Except for collectibles, for the standard deviation, it's still a little bit high.